Hello class, in this video I wanted to review linear equations and functions from basic algebra and talk about, how we can use them and getting into, well, what changes about functions. And what I wanted to start off by reviewing are the different forms of linear equations and talk a little bit about why those work the way they do and why we care. There's two major forms of writing an equation of a line, which a linear function is always a function which is its graph is always that of a straight line, hence linear. But basically, it's always an equation where y is equal to x times and plus or minus something. And often we refer to it as y equal mx plus b, or in the case of a function, f of x equal mx plus b, because a straight line is always a function because it passes the vertical line test. Unless it was a vertical line. That is the only linear equation which is not a function. And if you recall, vertical lines have equations, for example, x equal 5 or x equal 0, something like that. Whereas horizontal lines are okay to be functions. They have the equation y equals. And because it's y equal mx plus b, you could just substitute y with f of x. Hence, it would change from a linear equation into a linear function. But otherwise, all other traits about those linear equations remain the same. And if you recall, m stands for the slope of the line, which is a quantitative measurement for how steep it is. So higher slope means steeper line, lesser slope means more gradual. So typically, if the number is like 2, 3, or 4, it would have a very steep slope. But if it was a fraction like 1/3 or 1/4 or 1/5, it would have a very gradual slope. And the sign of the slope m, whether it's positive or negative, has to do whether it's increasing or going up versus decreasing. So it looks like I'm backwards on my video. So, an increasing slope or a positive slope would look more like this, whereas a decreasing slope would look more like this in terms of its direction. So positive means going up to the right, negative means going down. And b, hence the name slope-intercept form, is always going to be the y-intercept of that function. And so one of the main purposes or usefulness of such a formula, y equal mx plus b, is if we have a line and we can tell what its slope and what its y-intercept would be, we could actually write its generic equation. Or if we're dealing with a linear function, we can understand some of the graph, exactly what the graph is going to look like just by interpreting the slope and the intercept from the formula of that linear function. Now, sometimes linear equations are written differently. Like, we often have a linear equation, what we call standard form, or not everybody would call it standard form. It depends on the source. But these sorts of equations, like you might recognize 3x plus 4y equal 11, something like that, are very common in systems. And when it comes to computer programming and various other applications, it is more useful to write an equation in such a form instead. And I wanted to mention you actually can tell the slope and the intercept from this. There's a simple formula for doing that. And really, you could always solve for y in the formula to figure out the slope. But if you were to solve for y, you'd have to subtract ax to the other side and divide by b. So the slope you would end up with would be negative a over b, which would always be the slope from an equation written in standard form. And the y-intercept, which would be the constant term, would just be c divided by b as well. So, there's an easy way to interpret that information from this form, but you actually have to do a little math and thinking to get there. Now, the third form of a linear equation is called the point-slope form, which is less useful for, we don't typically leave equations in this form or express them in this form, but this form is very useful for taking information and translating it back into an equation. Now, I mentioned a minute ago that the slope-intercept form is useful for writing equations because if I know the slope and if I know the y-intercept, I can just plug in m and b, and I will have the equation y is equal to 1/2 x plus 5, or Again, whatever those numbers may be. But the issue is sometimes we have a line, but we don't necessarily know what the y-intercept is, because in some cases it might not even have one. Well, in a real problem, that is. So point slope form is a little bit more useful because instead of needing specifically the y-intercept, we can use any point labeled as x1, y1 and the slope to craft an equation from this form as well. And so often when you're asked to write an equation or write a function, it's useful to start with the point slope form. That way you will be able to write that equation effectively. So I also wanted to talk a little bit more about each one. So I wanted to, just discuss, well, I don't know if you've ever wondered this, well, why is m the slope and why is b the y-intercept? How does that make sense? But if we think about how the function will operate, well, remember that the y-intercept always occurs when x is 0, as I said a few videos ago. And if we think about what would happen if we plug in 0 into f of x, we'd have f of 0 is equal to m times 0 plus b. And of course, anything times 0 is 0. So what we're led to believe is that the y-intercept, which is f of 0, is equal to b. And that's the very simple reason why b is the y-intercept for a simple linear function. And now m we could look at in a very similar way. We could change from the y-intercept, which occurs at b. So imagine that on our graph here, b is where our y-intercept is, whatever, it doesn't matter what it is, but we have some point. Now, let's say we were to look at what happens as we move through the line. Let's say we plug in 1 for x or 2 for x. What would then happen to b? Well, obviously, if I plug in 1 for x, I would have m times 1 plus b, which is just m plus b. So notice that f of 0 is b, but f of 1 is m plus b, meaning that I've went from that b height and I've added m to it. So basically, as I move to the right 1, I'm going to rise m. We often refer to the slope as the rise over run, because as I run 1, I rise by m, which is the slope. And if it's a fraction, it's the same idea, but you can just break down that degradation into 2 parts. The top of the fraction is how much you've risen, and the bottom is how much you've ran. And we'll review slope in the video soon. And then if I run 1 more unit to the right, so if I go then x is equal to 2, that would leave me with 2m plus b, and I've risen another m. So it would be starting at b, then b plus m, b plus 2m, and it would keep going up the same amount each time, which is what causes these functions to have a consistent slope and rise the same amount due to their linear nature. We sometimes call linear functions like this polynomials of degree 1 because x is not squared or anything like that. It's just when you have just a simple linear equation. What's different about, well, I don't want to get into that right now, but basically you just have x and you're using basic arithmetic upon x. Multiplication, adding, subtracting, dividing, but nothing crazy is happening to x. I already talked about standard form earlier. And yeah, I think I mentioned already how point slope form works. So I'll go ahead and wrap this video up. In the next video, actually this brings me to another point about point slope form. A lot of times in statistics or in other aspects of mathematics, we often want to find what's called a trend line, or we might have a data set and we want to know, well, what is the approximate trend? What's the average nature of this set of data? And so in statistics, you learn how to best approximate a trend line, which involves just a lot of calculation based on the data. But if you pick 2 data points which are roughly in the center, it's not exact, you can get an approximating trend line for that data, which we'll do in our first class activity on Wednesday. But the idea is, if you have a data set and it looks like it's distributed linearly, we could find 2 points which model that data, create a line by using point slope form, right? Once I figure out the slope, I could use 2 points on the line to find the slope, and then I could just pick another point to actually craft the equation. Then the idea is that that equation or that linear function is a prediction model for more data points. Like if we're trying to guesstimate what would happen to someone in that data set, we could use that to find our correspondence. Like say, for example, the x-axis was someone's height and y-axis was someone's weight. Now these numbers don't make any sense for that example, but usually as someone's height goes up, their weight goes up on average, though you do have outliers. Anyways, you could get kind of an average model which is exhibited by that line.